Hey everybody, we're going to be going over what is a function. So, if you imagine a machine and you plug certain things in to that machine, and you also get certain things out. So there's an input and an output. And the machine does something. So let's make this the 2x machine. What happens in the 2x machine? Well, if you put in a value, say, I don't know, let's say 3, you plug that in, it gets replaced into the x. So this is 2 times 3. This 2 times x became 2 times 3. And it spits out a 6. Okay, let's try that again. Let's see if we get the hang of this. All right, here's my 2x machine. I'm going to plug in a value. Let's make it, let's say 5. So let's plug in 5 into this machine. 5 goes in, and then 2 times x, so 2 times 5, ding, 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 out comes a 10. So that's kind of an ugly 10, but out comes a 10. And so the machine just took the 5 that you plugged in, and it spit out a 10. This can also, so sometimes I don't want to write the whole box. We don't want to have to geez, every time I plug something in, I'm going to write that big old box. No. And that's why we have a certain notation called f of x. Okay? F of x does not mean f times x. F just denotes that there's a function. And so in this case, the function is 2x. And what you plug in, that red value there, would be the number that you're replacing x with. So as we can see here, if we plug in 3, that equals 2 times 3, which if we do the math, gives us 6. Likewise, on this side, we still have the same function, f of x equals 2x. And this time, we're going to plug in 5 and see what that gives us. So here we plug in a 5. And so we have 2 times 5 now. 2 times 5. Make sure that multiplication shows up. 2 times 5. And that, of course, equals 10. And so this number is this one right here. And this number is this one right there. And so you're just plugging in for x. You're replacing the x value with whatever you're plugging in. Let's do one more example. Why don't you try and see if you can get this one. So let's say we have the same function, f of x equals 2x, and this time you are going to plug in 7. 7. What is that? Pause and try. Okay, so here is the box, and I'm going to do the same machine again. We have in the machine 2x, which, again, 2x is really 2 times x. And we have an input, and we have an output. So we plug something in, and we get something out. And we're going to plug in 7. So the 7 goes in the machine. 2 times 7. 14. Ding! Out comes a 14. Let me put an arrow. Spits out a 14. Okay, so the machine, all this machine does is just multiplies by 2. Now, there are other machines that do different things. So, for example, you can have a 3x minus 1 machine. Just saying. What happens if you plug in values here? Let's plug in 7 to this one. If we plug in a 7 here, the 7 goes in. 3 times 7 minus 1. 21 minus 1. 20. Ding! 20 is the answer. So in this one, you plug in 7, you get 20. But on the last one, when we plugged in 7 over here, we got out a 14. because the machine is different. It does different things. How would we write this for function notation? This would be f of x equals 3x minus 1, right? This defines what the machine does to the number. And it is followed by what we plugged in. So we plugged in a 7. And this is where some people get confused. They don't know what to do with this 7. If you notice here, this x became 7. So guess what? This x must become 7. So we have 3 times 7 minus 1, which is 21 minus 1. Oh. 21 minus 1, which is 20.